mostly we're dealing with series. Now in parallel, calculate the following. Can we do that quickly? Let's try to sketch that. These are parallel capacitors, so you expect them to be like this, and then another one like that. See what I'm doing there? And then you continue with our combination of parallel like this. So these are parallel capacitors. Okay, so you can actually end there, and then we can have in here our, of course this must be complete circuit there. We can have in here our voltage, our voltage potential across. All right, so then we can now label them. What is it? This is, we can call this C1. Let me do this. We can call this C1, which is 20, let me say equal to 20 microfarad, and then we can call this C2 equal to 40 microfarad. We can call this C3 equal to 80 microfarad. This is what you're having. And then they're saying they're connected. Calculate the following: the total capacitance. Now let's back. Hello once again, our most developed student. My name is Confident, and welcome to the ultimate guide in industrial electronics for N1 students, and it has everything you need to know to prepare for your final exam. It's a 13-day intervention, and in this intervention, these are the modules that I'm covering, and this is what I'm going to be trying to assist you. Look at this question here. It says capacitors, two capacitors with values of 90 microfarad, 15 microfarad are connected in series. Calculate the total capacitance of the circuit. 4 marks. Guys, how do you approach such questions? You cannot afford to get them wrong. Hence, I'm saying here, in this intervention plan, as you can see, the focus is on capacitors. I have already done resistors, I've already done conductors and insulators, I have already done the basic atomic theory. I will encourage you, go back to the videos that are previously, check our 24-minute lesson. If it's the first time coming in contact with this channel, if you are new, then you need to be subscribed. Get hold of the videos and you will never ever regret it. So let's look at capacitors and work them out in a way that will simplify everything. It says two capacitors with values of 90 micro. See, whenever I say micro, my head goes up and say, that's not the SI unit. It must be on the farad. And then 15 microfarad are connected in series. Calculate the total capacitance of that. So what we are having here, we are just having something like this. This is my capacitor here. Must be just parallel plates. And this is my other capacitor. These are in series, right? And then what you have, okay, I'm just trying to do this for the first time here. So this is what you're having here, like this. And then these capacitors, they are saying the other one is 90 microfarad and the other one is 15 microfarad. And they say calculate the total capacitance. Now you cannot work them out without you familiarizing yourself with the formulas. Now I just want to say something with these formulas. You see, when it comes to capacitors and resistance, just remember this. You can do that on your formulas to say these are, these are resistors in series. Now the resistors in series, the formula you use for resistors in series is the formula you use for capacitors in parallel. So series resistors for capacitors, it's in parallel. So if I'm talking about this formula here in capacitors, this is for parallel. You see the difference? And then if this is for parallel, you just remember the resistors. Then you come here and say this is for series. So there is the formula. They say two capacitors in series 1 over CT is 1 over C1, 1 over C2, and stuff like that. So let's go there. They say here, if I'm using the formula, 1 over total capacitance CT is 1 over C1 plus 1 over C2. You see? So then, as I say to you, remember, okay, let's write this one. First state the formula is very important, which is 1 over 90 plus 1 over 15. Now remember this, when you're finding CT, I've been emphasizing, you say 1 over, then you say 1 over 90 plus 1 over 15. Are you with me? Then it will give you now the total capacitance, like we did with resistors in parallel. Just saying 1 over, just doing that, 1 over and then 1 over 90 is the simplest way to avoid errors. So you say 1 over, then fraction, 1 over 90 plus 1 over 15. If you have been following my previous videos, you will simply understand why it's like that, which is 12,857. So it's 12,857. Now, what is the formula for capacitance? Remember, we are measuring in micro. Okay, this one is microfarad already. So I never changed units, so it will be in microfarad. But if you wanted to convert everything, you are going to say 12,857. Micro means times 10 to the power negative 6 farad. Or you divide by what? You divide by a million. But whenever they want total capacitance, you don't need really to convert. You can continue working and maintaining your units as they are. Alright, so that was the first one. Now let's go to the next one. The next question is 3 capacitors with values, that one, and that one is in microfarad, are connected in series. The combination is then connected across a voltage, applied voltage of 240 volts. I'm just going to try to draw this also quickly. Next time I'm not going to be sketching this. I'm just trying to show you how you can be, in a way, sketching these diagrams. All right. So this is the capacitor in what? In series. See that? And then they are saying here there is a voltage supply here, like this. And then what is the voltage supply? They are telling us the voltage supply is 240 volts. And then they gave us the capacitors. This is more like your C1, your C2, your C3, which is 1,4 is microfarad. Don't forget 2,8. The units are very important. 5,6 is microfarad. Now, 4 marks. Calculate the total capacitance. Now, you still remember these are what? In series. So let me come here and say series capacitors. We said series, you use the formula for that. Remember I said always interchange with the resistance. You know that resistors in series is the capacitance in parallel, you know, so the formulas in a way. So we see this parallel and series is like it's opposing one another. For resistors it's in parallel, but for capacitors it's in series, just the other way, one way or the other. Now let's look at this. Calculate the total capacitance of this. So what you do here, we are applying the formula 1 over CT is equal to 1 over, but because I'm still finding the total capacitance, I don't have to convert these units, plus 1 over 2,8. I can work like this, 1 over 5,6. Are you with me? And then it will give me now, look at this. I said to find CT, it's better to say 1 over, then you maintain 1 over 1,4 plus 1 over 2,8 plus 1 over 5,6. It gives you directly CT. Are you with me? So then if we can use that, I'll be having here 1 over, then 1 over 1,4 plus again 1 over 2,8 again plus 1 over 5,6. All right, there is the answer. it's 0.8. So I get 0.8 watt. It's microfarad. Don't forget to maintain the units. So that is 4 marks. Then next one, calculate the charge across the circuit here. Calculate the charge. Now if they want to calculate the charge, which is, this was question 1, question 2. To calculate the charge, let's go to the formulas again here. In the formulas, when it comes to charge, it follows immediately after. Look at this. There is the charge, QCV. You see that? Now, if I can come back here and say, you need to know that formula. Q is equal to CV, meaning C times V. So you need to know what is Q. Q stands for the charge. C stands for the capacitance. And V stands for the voltage across. You understand? So that is that. And you must also remember, you can use this formula like this to come up with a what? That triangle. In that triangle, what are you going to say? We are going to say it's CV, it's QCV. See that? Then it can help you to find capacitance. It can help you to find voltage. So you're going to say C is Q over V and V is Q over C. So this can also assist in that. But here they wanted the charge. Q is equal to CT. Since now they said the capacitance across the unit. So that's why now I want you to be careful. What you need to do is first convert this 0.8. So you're going to say CT, which is 0.8 divided by a million, or you multiply by 10 to the power negative 6. If it's easy, micro means divide by a million, and then you multiply by voltage, and they told us the voltage is 240. So multiply by 240. That's the V. Remember, the voltage across. That's what they said. The applied voltage. So you divide by a million and that, then you get your Q here. It's just something straightforward. You don't need to strain yourself there. So there it is 0.8 divided by 1, 2, 3, 4, 5, 6, or you multiply by 10 to the power negative 6 times 240 equal to, then you get 1.92 times 10 to the power negative 5. 92 times 10 to the power negative 5 watt. Now charge is in coulombs. Don't forget that. C. That's how you calculate this. The voltage is in volts. The charge is in coulombs. The capacitance is in farad. Alright. So that was that. Now guys, before I move on, I just want to remind you again, if you've been watching our videos, I think I made it clear that these videos are sponsored by Ekurhuleni Technical College. It is a corresponding college that deals mainly with N1 to N6 engineering as well as business studies subjects. They specialize mainly with correspondence, whereby in this correspondence you'll learn from home, distance learning by the way, and look at their courses that they're offering, including installation rules. So this is the installation rules exam taking place. As I say, it is distance learning. Check out their website, check out their courses, and also you can find out if maybe it might be the college that you can enroll with in the coming exams. You might get it more useful also. There are also videos in terms of other subjects. Not every subject from what I know, just the limited subjects they are rolling out videos, so it can be good for someone who is employed or who doesn't have the time to attend classes. So check them out, it might come handy. Alright, now next lesson, next part, we are looking at what now? We are looking at capacitance. 4.3. It says 3 capacitors with values 1 to 3 respectively are connected in series. You see, the moment they say series and capacitance, you know the formula, 1 over CT. Now do this one for me so that you can compare your answer. Just pause this video, work it out and see what you get. So it's 1 over C1 plus 1 over C2 plus 1 over C3. Alright, and then from there you know what to do. You put these values to say 1. Now you know what I do. I'm just gonna go straight to the answer now, to say my CT is equal to 1 over, and then I'm gonna have 1 over 1,8. Remember though, it's microfarad, plus 1 over 2,1 plus 1 over 10. I'm just saving time here. And then CT, it is fine for you first to put the values for C1 there, C2 and C3. Alright, but me, I just went straight to the answer there. But remember, to say CT, you just say 1 over, and then you put fractions now. 1 over 1,8 plus 1 over 2,1 plus 1 over 10, right? And then you get your answer, which is 0,88359, which is 0,884. 0.884 what? It's microfarad. But remember, if this question continues and say calculate the following: the charge across the circuit with an applied voltage of 100 volts. The moment they now put about the charge, what you need to do, remind yourself of the formula. I think the formulas are here. Remind yourself of the formula. Just under capacitance is the formula for the charge. Q is C times V, and then you apply that formula now to say Q is equal to C times V, and I told you what to do to the capacitance. You take that C, 0,884, you divide it by a million. Micro means divide by a million. Or you can do this, or let me do it on the sides. It's same as saying 0,884 times 10 to the power negative 6. Still the same. That's the C times your 100. If you write this, you'll get the same answer. So me here, I'll use that and then multiply by 100 volts, because they said across with a 100 volt, and then you get your answer, and then that is it. Complicated? I don't think so. So let's do that, which is 0,884 over a million. I hope I did right, times 100. I was just playing this fast. I hope it worked. 8.84 times 10 to the power negative 5 times 10 to the power negative 5 what? Coulombs. Don't forget that. Alright, so that is that part. We can move on now to the next one, but I hope it is making sense. If you are benefiting from these channels, then guys, I also encourage you, keep subscribed, because there is mathematics, there is engineering science, there is now industrial electronics, soon there will be electrical trade theory, and more and more and more. Just make sure that you are enrolled into this. I mean, we are what can I call it? Make sure that you are subscribed into this channel. All right, now 3 capacitors with values 20 microfarad. These are connected now in parallel. Look at the change. Mostly we're dealing with series, now in parallel. Calculate the following. Can we do that quickly? Let's try to sketch that. These are parallel capacitors, so you expect them to be like this, and then another one like that. See what I'm doing there? And then you continue with our combination of parallel like this. So these are parallel capacitors. Okay, so you can actually end there, and then we can have in here our, of course this must be complete circuit there. We can have in here our voltage, our voltage potential across. All right, so then we can now label them. What is it? This is, we can call this C1. Let me do this. We can call this C1, which is 20 let me say equal to 20 microfarad, and then we can call this C2 equal to 40 microfarad. We can call this C3 equal to 80 microfarad. This is what you're having. And then they're saying they're connected calculate the following: the total capacitance. Now let's go back to those formulas. Remember, we said, or I said, when you're comparing these to resistors, resistors are common. If you say here on the series resistors, these are series resistors. Now for series resistors, again, you look for the formula that you're going to do. Is the formula here for series is like this. You see how it compares? The opposite. So instead of thinking this is parallel, you go for series, and then these are parallel. The formula for parallel resistors, but you use the formula for parallel. Look at the formula for parallel. You compare. Parallel is the series on the other side. You just interchange, meaning CT C1 plus C2 plus C3. So here, like that, it does the same to say CT is C1 plus C2 plus C3. You see that? Then after that you say CT is what? 20 plus 40 plus 80, which is what? I think this is 140, but don't forget you are dealing with microfarad. Then the last one, the charge across the circuit with the applied voltage of 36 volts. So now the voltage, remember the formula doesn't change. Q is equal to C times V. It's still the charge across, but I told you what to do to the 140. I can use the other method, which is 140. Instead of divided by a million, I can say times 10 to the power negative 6 times what? Times 36 volts. See that? Which is equal to, you'll see, I'll just write the two answers. It will give me the same way. If I say here 140 times 10 to the power of negative 6 times 36, look at the answer I'm getting. I'm getting 5.04 times 10 to the power negative 3. This is same as saying put a fraction, 140 over a million. This is my million times 36, which is 5.04 times 10 to the power negative 3. See, same answer. 5.04 times 10 to the power negative 3. What? Coulombs. Alright. So these are the formulas that you can be using in here. Next one. Let's look at the next question. What does it say? It says, make a neat labeled sketch to show the discharging curve for a capacitor in terms of voltage and time. Look, they mentioned voltage and time. So a sketch for the discharging of a capacitor. So what you'll be having here, you have it like this. They are telling you in terms of what? V, which is voltage in volts, time in seconds. See that? And then you draw it. It's just a nice curve that starts from there, it detaches there, and then exponential touches there. I'm not drawing it nicely the way I want, but nice curve. Come on, nice curve like this. Yes, are you getting that? That's it. Exponential curve, that's what they want. Now the second question, it says what? Show by means of a sketch. Again, they want a sketch, a voltage time, same curve of charging a capacitor. This is the opposite now. How do you charge a capacitor? Let's do the charging now. Similarly, you've got that. So this was discharging. Now voltage in volts, time in seconds. Now how do you charge a capacitor? So this is the part, this is the one that you're going to use. You're going to say in here, it's starting from like this, from 0. It's more like an exponential again, like this. It's more like I'm having, it's better if I'm drawing it like this. See? Then after that, it must become flat to say when it's full, there is no change with time. So it's more like that, still in a way like an exponential graph. So that's what you're having for the two charging. So this one is number 1 and this is number 2. When you're this is discharging and the other one is charging, so don't confuse them when you're charging it and when you're discharging. All right, next one, a 0.5 microfarad capacitor has a charge of that. Determine the voltage across the capacitor. Look, now they changed a few things. They gave you that capacitor. Remember, for the formula, it's Q is equal to C times V. Already they gave you what? A 0.5 capacitor, meaning 0.5 micro means divide by a million, right? Times the voltage, we don't know, is equal to what? Is equal to what? The charge, which is again, look, micro, which is 110 divided by a million. Whenever I say micro, it means divide by a million. But now there is a better formula you could have used here. I remember saying you can come up with this kind of a triangle. The moment you know one formula, look, if you have got C here and V here, Q doesn't tap. Now they want voltage. What is voltage? V is equal to Q over C. I think that, which is equal to Q. What is Q? Q there is 110. It's easier there to multiply by 10 to the power negative 6 over 0.5. Remember, dividing by million is same as multiplying by 10 to the power negative 6. But even if you didn't do it, look, the answer was going to be the same because that goes and that goes. So it's more like you're dividing 110 divided by 0.05. You see that? So it's 110 divided by 0.5, not 0.05. So it's 220 what? Volts. So that's our voltage. Like that. Difficult? I don't think so. Easy. If you're not careful, you might get it wrong. So just be sensitive to that. Move on to the next question here. It says a circuit consists of two capacitors with values that one and that one which are connected in series. Calculate the following. Now, this is what I suggest you do. Pause this video, read the question, attempt the first one, attempt the second one. Ask yourself, out of 7 marks, how many will I get after comparing yourself with the answers that I'm going to provide now. So the total capacitance, what are they in? They're in series. So 1 over CT, don't forget, series is 1 over C1 plus 1 over C2, right? Then CT, I'm not gonna, you write the value there on the next step, but me, I'll say 1 over 10 plus 1 over 15. Then it'll give me my what? My CT. I repeat, pause the video. Practice is important. If you guys are not going to, if you're just gonna spectate, you know, I'm not being rude, but if you're just gonna watch and spectate me like I'm acting a movie, unfortunately, you're not going to get it right. I have to be frank with you. You need to practice, you know, just like any other thing, practice makes you better. All right, there it is. The answer is 6. So there is 6. 6 what? What are you gonna write? Microfarad. All right, don't forget units, it's very important. The next one says the charge across the circuit with an applied volt of 12 volts. You know what to do now. That is question 1. Question number 2, the charge Q is C times V, which is equal to capacitance 6 divided by a million, or you multiply by 10 to the power 6 times the voltage, which is 12. Then it will give you what? It will give you your charge. Okay, so which is what? 6 over a million times 12. I hope I didn't put an extra 0 there, but it's fine. 7,2 times 10 to the power negative 5. 7,2 times 10 to the power negative 5. What are the units, guys? Charge is in coulombs. All right. So the next one, it says what? 4.8. There are 3 factors. Okay, it's a different one here. There are 3 factors that affect the capacitance of a capacitor. maybe this thing is now, let me do this. There are three factors that affect what? The capacitance of a capacitor. What effect will the following factors have on the capacitance? Now I will encourage you to know these factors. There are three factors. Number one, the distance between the plates, the cross-sectional area of the plates, and the type of the insulating material. They call also this the dielectric. Alright, the type of the dielectric. Now they're saying what effect will it have? Number one, distance. So let's call this 1, 2, 3. I'm not going to write it again. So what is the effect of distance between the plates? The further the distance, the lower the capacitance. I'm saying that. So which means if the distance is longer, the capacitance decreases. Capacitance. Another statement you can use, you can say distance is inversely proportional. You see, when one increases, one decreases, it means it's inversely proportional to capacitance. Okay, then next one, number 2. What is number 2? Number 2 is talking about cross-sectional area. So what are you going to say? The larger the area, you write cross-sectional area, the higher the capacitance. The higher the capacitance. You know what you can also say? You can say area is directly proportional. Area is directly proportional means when one increases, the other increases. Directly prop to capacitance. I'm not gonna finish. Area is directly proportional to capacitance. The type of what? The type of insulating material. Now number 3, this is how you can put it. Number 3, it's a bit confusing, but you can use it like this to say some materials you can say are poor what? The type of insulating material I told you is a dielectric. A poor dielectrics and have lower capacitance. Do you see how it relates? So the poor the dielectric, the lower the capacitance. And some are good dielectrics, or you can say good insulating materials and have what? Higher capacitance. I'm trying to avoid the way to say the stronger the dielectric, the higher the capacitance, or the dielectric is directly proportional to capacitance. I'm trying to avoid that, but you can say good dielectrics result in higher capacitance and poor dielectrics result in lower capacitance. This is what you could have said in this kind of equation here. I hope this helps. Let's continue. We're just getting there, almost finishing. A series circuit consists of 2 capacitors with the following values, that one and that one. Determine the following. Guys, it's repetition. You master this, you're good to go, especially the one in series. 1 over CT. Okay, I can actually even write the answer now. Remember, you've been working on this. It will be 1 over, you know the formula, 1 over 10 plus 1 over 20, and then we just can just get CT straight. Compare your answer against mine, then you will be good to go. 1 over 10. As I said, don't spectate, guys. Be active on this channel. We look for people who are active, 6,667. 6,667 what? Microfarads. Always maintain that. The charge across is 10 volts. What do you do? Q is C times V. And I told you, you don't just say C and take it like that. You say 6, what? 667. It's either you divide by 1,000,000 or you multiply by 10 to the power -6, please. Or, easier one to remind yourself, it becomes better, divide by 1,000,000. You see? And then times times what? 10. And then you get the answer here. You still want me to do it for you? Okay, let's do it. I'll find you the answer. Since you want to spectate, guys, I'll do it for you then. Okay, 6,667. Yes, I'm watching you. You are looking at me like that. Work it out, my dear. Work it out. It is going to assist you in your final exam. I'm joking. I'm not seeing you. 6,667 times 10 to the power negative 5. 6,667 times 10 to the power negative 5. What? Coulombs. SI units. All right. Not bad. Not bad. Almost getting done. I think there is the last one. What is this one saying? 3 capacitors with values blah 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 are connected in parallel. Well, we're getting another version of parallel, and remember, parallel means use series circuits in resistance. What you do for resistance in series is what you do for capacitors in parallel. So what you do, CT is C1 plus C2 plus C3. Now CT is 10 plus 5 plus 25. What is this? 5 plus 25 is 30. This is 40 what? Microfarad. That's your CT. Now, then it says, calculate the following. It has got 100 volt supply. Obviously, keep that. Then when they want the charge, that's when you can say Q is equal to C times V, which is equal to 40 divided by a million, right? Times what? Times 100 volts. So I hope you tried it yourself. Check your answer, and guess what? This time I'm not going to show you. I'm serious. You need to calculate. Get your calculator and do it for yourself. I cannot be doing everything for you. Anyway, I'm joking, but just guys, try it out. Let's get the answer. In case you say you are not going to watch this channel again, I'm just joking, guys. 3, 4, 5, 6. I sometimes add an extra 0 by error here. This thing, when I press it, it just starts running with zeros, you know. It likes it fits on zeros. 4 times 10 to the power negative 3. You always know that the charge is in coulombs, okay, guys? So this is what happens when you start doing this. You get so much comfortable with them. At the end of the day, they become easier to solve. But practice makes perfect. But before, this is the end of the lesson, but I'll say, just before you go, wait before you go. Remember, this video has been sponsored by Ekurhuleni Technical College, and they offer correspondence or distance learning from installation rules, N1 to N6 engineering studies. You talk of your boilermaker, instrumentation, rigging, welding, electrical, mechanical. This is their details. Please check them out if ever you want to do something related to distance learning. Mainly, they do have part-time, they do have full-time, but mainly it's distance learning. It can come handy. Their location is in Krugersdorp. Guys, we have come to the end of our lesson. Now, what is next? I have a date with you again. The next one is inductors. Look at it. Inductors. You cannot afford to face that exam without knowing what to do on inductors. I'm here to get all the challenges out of it so that you can know what to do and you won't regret that. Join me in the next lesson 5 on inductors, and I hope these lessons are of benefit to you. Remember to subscribe, remember to ensure the notification bell is turned on, and also remember to leave your comments. Guys, by the way, there are boot camps for maths, science. We might be adding also for industrial electronics. Check out this website, which is www.24minute.co.za. I think it's also in this part. Where is it? Let me just check there. 24-minute lessons, you know. So if you check this website, it's not showing here, but it's www.24minute.co.za. You'll see our boot camps where we have got a high intensive 5-day preparation for your exam if you want a one-on-one. we've come to the end of our lesson. Thank you.